Hello everyone, welcome to this tutorial. In this video we're going to learn how to derive the length contraction expression of a rod in a moving frame and in a stationary frame. This equation is a consequence of the Lorenz transformation. There are two major consequences of the Lorenz transformation. The first consequence is called the twin paradox, or one may also call it the time dilation of a clock in a moving frame. And then there is also the length contraction of a rod in a moving frame when it is moving with respect to an observer in the stationary frame. So if you were to derive the length contraction, if you were asked to derive the length contraction of a rod as a consequence of Lorenz transformation, how would you do that? So that's what this video is all about. Now, we have two frames here. The first frame is the stationary frame, and I'll call it S. And the second frame is a moving frame. This frame is moving with respect to this frame, and I'll call this frame S prime. So these two rectangles you see here, this is the rod in the moving frame and this is the rod in the stationary frame. So all these are axes in the moving frame and in the stationary frame. So if an observer stays in this frame, how would he see this rod? He will see this rod as having coordinates, the last part of this rod to be x2 prime. This he would call x1 prime. Now that is for the moving frame. Now if you talk about the stationary frame, how is it going to be called? This is just going to be called x2, and this particular side is just going to be called s, just x1. So that's how it's going to be called. Now, there is a difference between the observer seeing this rod in this frame and the observer that sees this rod in this frame. There is going to be a difference. So, length contraction expression is the kind of expression that relates these two expressions, the lengths of these two rods in one equation. So, the observer in the stationary frame sees the rod's length as L0. So we'll call the length of this rod in the stationary frame as L0. That is how the observer in this frame is going to see this rod. So let me call it L0. So this is going to be L0, and L0 is equal to x2 minus x1. So if you subtract x1 from x2, you find the length of that rod totally. Now the observer that is in S prime frame, that is the frame that is moving with respect to this stationary frame, and this moving frame is called the S prime. An observer here will see this rod as L. So I'd write that there. The observer in the moving frame, and the moving frame is called S prime, would see the rod's length as L. So we just call this L and we call this L0 just to differentiate the two ways, or the two different observers we see these rods in their various frames. This observer will see the rod to have a different length from this observer here, but the length contraction experiment is an equation that will help us to unite or to mix together between this length and this length, so that if you were in the stationary frame, you could also calculate the length of that rod in the moving frame. So the L is equal to x2 prime minus x1 prime. So the Lorenz transformation equations are, we have x prime is equal to x minus vt over square root of 1 minus v squared over c squared. Then we have y prime is equal to y. We have z prime is equal to z. And then we have t prime is equal to t minus vx over c squared all over 1 minus v squared over c squared. If you want to know how these equations were derived, you will look at my other video which I'm going to upload to this channel on deriving the Lorenz transformation equation. And also, if you have not subscribed to this video channel, make sure to subscribe to it, because we'll be uploading videos on tutorials in physics, in chemistry, and in math. So you do well to subscribe so that you see popular uploads of videos as soon as I post them, and ensure also to click the notification button so that you always get every weekly upload of videos on this channel. So now these are the Lorenz transformation equations which I am going to use to substitute into these two equations I put here, so that I'll be able to come out with the length contraction expression. So if we have x prime is equal to x minus vt over square root of 1 minus v squared over c squared. Now if I said I'm going to make x the subject, that is now going to be x prime plus vt over square root of 1 minus v squared over c squared. So that's what it's going to be. Now in this place, now I'll need to get my x2. So my x2 would be x2 prime plus vt over square root of 1 minus v squared over c squared. And then x1 would be x1 prime plus vt over 1 minus v squared over c squared. So if I want to find the length, of the rod in the stationary frame, S, so the length of that rod is given as L0, and L0 was equal to x2 minus x1. So that's going to be, if I were to substitute the formula for x2 which we found in this place and the formula for x1 which we got in this place, that's going to be x2 prime plus vt over 1 minus v squared over c squared minus x1, which is this formula you see here. So there's going to be x1 prime plus vt over 1 minus v squared over c squared. So in this place now, the next thing we're to do is to get the LCM of these two denominators which we see here, and the denominators would have the same square. The denominators will be the same, so they have the same LCM. So I just pick one of them and it becomes the LCM for these two fractions here. So if I say this squared this expression into this is going to be 1 time, and 1 multiplied by this will be x2 prime plus vt minus this into this is going to be 1 multiplied by this numerator here going to be x1 prime plus vt. So that's what you find there. Then L0 will be equal to x2 prime plus vt, and if I had used this negative to open this bracket, that is going to be minus x1 prime minus vt over 1 minus v squared over c squared. So since I have the same terms here as vt and I have vt, I collect like terms, so I bring x2 prime minus x1 prime there, and then I have plus vt minus vt there. So this will cancel this out since you have vt minus vt. Then we have it all over 1 minus v squared over c squared. So this is now going to be L x2 prime minus x1 prime over 1 minus 2 v squared over c squared. So L0 is equal to, Now remember, this L was equal to, just like you can see here, L is equal to x2 prime minus x1 prime. So it's the same thing here. We have x2 prime minus x1 prime, and x2 prime minus x1 prime was already L. That is the length of that rod in the moving frame. So instead of writing x2 prime minus x1 prime, I'm going to write L over L1 minus V2 over C2, V squared over C squared. So this is now equal to L0 is equal to L over 1 minus V squared over C squared. So this is the final answer, and this is the expression for the length contraction of a rod as a consequence of the Lorentz transformation equations. Make sure to subscribe to this video so that you can get all uploads as much as we're bringing them on this channel. Thank you.